quadratic equation looks like this. Y equals ax squared plus bx plus c. We've been working with that for a while now. Working just your generic run-of-the-mill quadratic equation. The a's, b's, and c's are just the coefficients themselves. Well, what happens when you go to graph these things as opposed to just, typing it into your calculator, there's a very simple process to graphing. I'm going to walk you guys through this very easy process. I like to just use numerical examples right off the bat. So let's see, y equals ax squared plus bx plus c. So the first example I'm going to use is the following. And notice, I'm not bothering with graph paper, nor should you. I don't want to see graph paper. You don't need it. I know some of you guys use graph paper right off the bat, but you don't need graph paper. What you're going to be doing is you're going to be giving me visual representations with specific parts. And it's a very easy thing to do. So we're going to take the graph of 2x squared minus 8x plus 6. Well, we all know that parabolas go one of two ways. Up like a cup or down like a frown. Do you guys agree?
Yes.
Now, what if I told you that not only is there up like a cup or down like a frown, but there's sideways ones? We talked about that, right?
Yeah.
All right.
Not really, but
We will talk about them more next week. Just so you guys know. But for today, it's either up like a cup or down like a frown. When I look at this standard equation, you know which direction it's going.
yes.
Which one?
Up like a cup.
It's up like a cup. And the reason you do that is because of why?
The A is
The A is positive. This is something you've known for a while. We know that this graph is going to do this. I don't know where it's going through, nor do I care. But here's how we figure this out. We know that since it's up like a cup, we know that this point here is called its what?
Minimum.
Minimum. Very good. It's also called the vertex. Okay? Your minimum or your maximum always occur at the vertex of a parabola. We talked a little bit about that when we were graphing and finding max and mins. So here's how you find that. These are the steps to graphing when you're working in standard form. Step 1, find axis of symmetry. Remember when we talked about parabolas being symmetrical? They could fold in on each other. Well, they fold in over this, what they call an axis of symmetry. Since our parabolas are either up like a cup or down like a frown, our axis of symmetry is nothing more than a vertical line.
So to clarify, it's up like a cup if the A is positive and down like a frown if negative.
Yes, sir? Now, what happens is that you get this vertical line for an axis of symmetry. What's the equation of every single vertical line?
0.
No. X equals something. X equals a number. All vertical lines are written as x equals a number. All horizontal lines are written as y equals a number. So what we do here is we find this axis of symmetry. And to do that, it's x equals the opposite of b over 2a. Okay? Oh yeah, you kind of vaguely remember that now, don't you? Now, in this case, what's the opposite of negative 8? 8 over 2 times 2. So what's 8 divided by 4? 2. So that means my axis of symmetry is at x equals 2. We okay with that? Now, when you graph axis of symmetry, whether it's going to be the vertical axis of symmetry for the x squared parabolas, or next week we graph, we graph the horizontal axis of symmetry for the y squared parabolas, make sure you put them as dotted lines. Because it's really a line that you don't see. It's just there to help us plot points. Okay? Now, what happens here with this axis of symmetry is that it is an x value. It's x equals 2. Well, doesn't your vertex land on that axis of symmetry?
Yes.
So the second step here is to basically find your vertex. your vertex is going to be located, well, in our example, we know the x coordinate is 2. What am I going to do to find the y coordinate?
Put it in the.
Exactly. I substitute back in. And it's that fast. Knowing that my axis of symmetry is lying at x equals 2, when I substitute in for x, it's going to generate y. So 2 times 2 squared minus 8 times 2 plus 6 equals y. No, that's just 2.
No, the y equal -2.
Oh, I'm sorry. I wasn't there yet. I'm like, oh, what? So what's 2 squared?
Oh.
4 times? Yes, ma'am.
Wait, so is there the step substitute?
Yeah. Find the vertex. Well, basically, it's find the vertex is that second step of substituting. Okay? So what's 2 squared? 4 times 2? 8 minus 16? Plus 6. Where's vertex? 2, negative 2. Very fast, isn't it? So I know that my vertex lies at 2, negative 2. I also know that you guys told me that it opens up like a cup. Do I need to find zeros? When I'm plotting these just to get a generic idea of where they're going, all I need to do is pick very easy points. What is an extremely easy value of x to substitute into that? 0.
So y equals 0 and y equals
Correct. Here's what I'm doing. Remember when we talked about parabolas before? And you guys had it in one of the word problems where you would find your zeros, and you know that somewhere in between lied that maximum value.
Yeah.
The reason we were able to do that is that these 2 points are equidistant to that axis of symmetry. They're what you call symmetric twins. So what I'm going to do here is find some value of x that's stupid easy to work with. 0. Because what's 0 squared? 0. Times 2? 0. Minus 8 times 0? 0. Plus 6? 0.
6.
So I know that when x is 0, what's y?
6.
How far away is this point from the axis of symmetry? 2. What's 2 more to the right of it?
2, 6. 4, 6. There you go.
What you're doing here is you're picking a point that's easy to work with. In this example, we're very close to x equals 0. Why not use 0? It's the easiest number to multiply. It gave me a y value very quickly. Knowing that 0 is 2 spots away from the axis of symmetry, since parabolas are symmetrical, 2 spots on the other side of it is 4. Therefore, it's going to have the exact same y value. It has to, because math doesn't lie. And that's how you graph in standard form. You give me a vertex, you give me an axis of symmetry, and a pair of symmetrical points. I just fudged the graph. It's not pretty. It's a generic representation of what it should look like. Make sense?
We might write out this stuff so
All
Like a
get your axis of symmetry by opposite of b over 2a equals your x. Get the vertex by substitution.
I kind of know how you got the 0, but at the same time, I kind of don't.
I just picked any number.
Read it.
I just picked any number out of thin
Because
air.
it's 2 on both sides.
Correct.
So basically, what you do to find the other one is go as many spaces as you need to
Yes.
hit 0, and then
Yep.
do the same the other way.
Now, for example, this came up earlier. What happens if my axis of symmetry is at like negative 30? Using 0 might not be the easiest thing to do. I might need to use like 22. Or you'll see how it goes with the numbers. You want to make the numbers easy to work with. And just by working with this a couple times, you see how really, really fast this is. So you get your vertex by substitution because your vertex will be your x and then the y. And then lastly, you just pick easy points. Pick an easy point with substitution again.
And that's just like a random.
Yeah. It's not like 11 billion. That's kind of a convenient number, but
11
like
billion.
6. That's all it is. You're just working through making it as simplistic as you possibly can. There's no reason for us to use a graphing calculator to go through tables and write all that out because it takes too long. Opposite of b over 2a, vertex, substitute in, pick a twin, and go. All right? The other method is your vertex form. Your vertex form is going to look a little bit different than what you guys have seen in the past. Vertex form is this. Vertex form is written as y equals a times the quantity x minus h squared plus k. This is your first introduction into what's called h and k. Your h and k is something that you guys have actually worked with in the past. You just didn't know you were. Can anybody tell me what this equation is called? That's point slope form, isn't it? This was shifting it a y value, this was shifting it an x value. When you shift something y, you're moving it up and down, right?
Yeah.
When you shift something by x, you're moving it left and right.
Yeah.
So this is a horizontal shift and a vertical shift.
Okay, first of all, there's no K.
I know, but you get the idea. All right? You get the idea. What we do in Algebra 2 is that every time we do graphing, we're going to have graphing of polynomials, graphing of logs, graphing of inverses, all this kind of stuff. There's always going to be this h and k value, this horizontal or a vertical shift. Your standard parabola would always start at the origin, 0, 0. This is telling me that it's just going to move over and up, or left and down, by that h and k. So here's what happens. When you have a vertex form, your vertex is at h, k. Vertex form is so nice to work with because it tells you right away what your vertex is. So numerically, example-wise, if I say that I have y equals negative 2 times x minus 3, quantity squared, minus 1, what's my h and what's my k? Is it negative 3 or is it positive 3? It's positive 3. Here's the thing. When you're dealing with, just like you guys did with your point slope form, remember it was y minus y sub 1? So if it was y plus 1, your y value is at negative 1. It's the same basic idea. You use the opposite sign for your h, the same sign for the k. I know this is the first time you've seen h and k. It'll get a little, you'll get the rust out real fast because we use it all the time.
You distribute the negative 2 first?
No. This is so easy to graph out of because I know my vertex for this example is at 3, negative 1. If my vertex is at 3, negative 1, where's my axis of symmetry? At 3. It's the x value. My axis of symmetry is at x equals 3. What's nice about vertex form, when you have vertex form, it's giving you your vertex and axis of symmetry right away. The a value tells you if it's positive or negative. So here my a value is negative, so what direction is this opening? Down. Means the same thing. So if you have a x minus h quantity squared plus k, your vertex is at h, k. Your axis of symmetry is at, x equals h. So you're 2/3 of the way done with the problem right off the bat. Let me show you what it looks like when I graph this. Let me put this on a separate sheet so I chew them all. If I have a vertex at 3 and -1, what quadrant is that in? 4. My vertex is there. My axis of symmetry is x equals 3. I have 2 things already plotted. What's the last thing I gotta plot? Symmetric twins again. So, what is going to be an easy number to substitute in for x? What's that? You guys, question.
Why does x equal h for the?
What's the? Remember we did the standard form. We got down to the axis of symmetry being the x value. Wasn't that the x value in the vertex? It's the same thing going backwards. The x value of the vertex is the axis of symmetry.
Okay.
Does that make sense? It's the same thing, just going both ways.
I got you.
I'll throw some geometry at you. It's biconditional.
Huh?
No.
What's a
No. It
biconditional?
can be said like backwards and forwards and
Okay.
contra and.
Now, once again, what's going to be a very easy value of x to substitute in to find a symmetric twin?
0.
0. What's 0 minus 3?
-3.
What's -3 squared?
9.
What's 9 times -2?
-18.
What's -18
-19.
minus 1? So it's way down here.
Yeah.
All the way down there.
So at 0 and -19.
Wait,
Do I have to mark off 19 spots to go all the way down there?
No.
No! That's a waste of time.
And money.
All we did here, guys, is to get that value. I took the equation of y equals -2, and I substitute in 0 for x. And that gave me the y value. It's direct substitution. It's using the table without the table.
Oh, yes. I completely understand.
Okay? I use direct substitution to get that. Now, how far away is 0 from our axis of symmetry?
3.
What's 3 more to the other side? At 6, it'll also be -19 then.
6.
When you're working with vertex form, it gives you 2 out of the 3 things you need to find. It tells you that your vertex is at HK. It tells you your axis of symmetry is at H. When it goes from there, it tells you to just pick any number to find your symmetric twins. Like I said earlier, not all of our axis of symmetries are always going to be so very close to the origin to get really nice to 0 all the time. It might happen. You never know. Okay? You just give me the hunchies. I just want to make sure you're all right.
What is the n?
Are you okay? Is it all right? That's the look of, dear God, I want to go home. Yes, ma'am.
Are they going to give us the equation in standard form or vertical form on homework or both?
Yes. And I'm glad you asked. There's one more.
Yes.
This is the easiest one.
I like easy. Is it graph form?
This is called, what do they call this one? Intercept form. Nope. Nope. It's intercept form. It's graphing via your zeros. It's graphing with zeros. You did this. You've done this. Trust me, I know you've done this.
You add the zeros and find so constant.
Y equals A. They use P and Q here.
P's and Q's.
Jinx.
Double G.
I can't say it unless it's a jinx.
Here's what this stands for. P and Q are your zeros. What happens halfway between your zeros? See, and I told you we knew how to do this. What do you think A is going to tell you?
And whether it's up or down.
Whether it's up or down. Okay.
Well, crud.
Let me show you an example. I think that intercept form is the fastest way to graph things because you've had a little bit of practice at this. We did that with some of our functions. You know, that's the 1,000 plus $200 extra in rent is 16 minus 110. We plotted our zeros, found the halfway point, and dun dun dun, there's your maximum or your minimum. It's the same flippin' thing. But numbers are easier now.
Oh, goody.
Yay. Let me show you an example.
I like you.
Y equals negative 2, x plus 4, and x minus, I don't know, 6. If I want to do that and graph that via intercepts, first thing I have to figure out is, what are my zeros? Negative 4 and positive 6. Everybody okay with that? Yes, ma'am.
Why is one -4 and one -6?
Set both of them equal to, well, one of them, it's positive 6. Remember you set both terms equal to 0?
Oh, okay.
We're solving zeros here. That's all we're doing, we're solving zeros. Now, what's negative 4 plus 6? Two. What's half of 2?
Uno.
Where's your axis of symmetry?
What about the vertex?
So my axis of symmetry is at x equals 1. And now, how do I find my vertex? I substitute back in. This, once you find that axis of symmetry, we're not doing the opposite of b over 2a. We're taking the midpoint of the zeros. Substitute in, and there's your vertex. So what's 1 plus 4? What's 1 minus 6? So what's 5 times negative 5?
Negative 25.
Times negative 2?
50.
50. So my vertex is up here at 1 and 50.
The axis of symmetry is the midpoint.
Yes, sir. Now, does this one open up or down?
Down. Because the 8 is a negative. Because it's negative.
Do I already have my symmetric twins sitting there?
Yeah.
The symmetric twins were the zeros.
Why? Why don't we have
There's
the
a
perfect high number?
Hold on. What's that?
The 4 plus 1 and then the -6.
I substitute extras for 1.
Oh,
Get my y down. X generates y. Yes, sir.
So we would multiply -2 by, like A by both of them instead of just like one, the first one?
No, because negative 2 times this times this. So you just multiply 3 numbers together.
Was
Okay.
the bottom just a random number?
No, it's what's 1 plus 4?
5.
What's 1 minus 6?
Negative 5.
So that's what we did. So we did negative 2 times 5 times negative 5. I got positive 2. Okay. Let me give you 6 of these to do for tonight. It's on section 5.1. It's page, what's page is this? 26 or 253, I think. Yes, it's on page 253. I like to do numbers 23 through 25, 29 through 31, and then 35 through 37. There's 3 of each style. There's three of the standard, 3 vertex, and 3 intercept. Please remember when you're doing this not to use graph paper. You want rough sketches, ladies and gentlemen. You want to, it's okay.
My entire homework thing.
That's, I know, but I don't want you to count them all, you know what I mean? I want a rough idea, because what I want you to do is give me those important points. Give me the vertex, give me the axis of symmetry, and give me my symmetric twins. All right? Very straightforward. I told you you knew how to do this.